Hey everyone, Baz here. So, I'm building this secure bridge between two companies, both on AWS, and it's all about sharing data and rendering in UI. To make it happen, we're using Apigee Cloud Edge as the super secure gateway. Think of it as a controlled access point. Now, the real magic is in the authentication. We're using SSO for login, generating JWTs, storing them in cookies, validating them with AWS KMS, and handling authorization, all in Apigee. The Lambdas on AWS Fargate handle the data processing, and the UI renders everything. It's all about trust and security, even within the same cloud. Let's break it down. On the Apigee Cloud side, left. API proxies, A, B, C. And these are the entry points for the Angular UI, acting as a facade by abstracting the backend logic. Common proxy manages shared functionality like authentication, authorization, logging, and rate limiting. Encrypted KVM, key-value map securely stores sensitive data, like API keys and authentication credentials, required for backend communication. JAS, an internal system involved in data processing or transformation before the request moves to AWS Fargate. On the AWS Fargate side, right. Lambdas, A, B, C. And these serverless functions are triggered by API requests and execute the business logic. Common Lambda handles shared logic across multiple Lambda functions. JAS, likely the same system used on the Apigee side, indicating a shared component or service. AWS environment, indicated by the AWS logo, showing the entire right side is hosted on AWS. Connecting the two sides is a secure channel represented by a key icon. This channel uses credentials stored in the encrypted KVM to establish a secure HTTPS connection, often through API keys or IAM roles. Here's how the data flows through our system. Angular UI request. A user interacts with the Angular UI, hosted via Apigee Cloud. This UI makes an API request to one of the API proxies, say, API Proxy A. Apigee processing. The API proxy receives the request and might apply transformations or policies. The common proxy handles any shared functionality required. The JAS system may process or transform data as needed. Apigee retrieves the necessary credentials from the encrypted KVM to authenticate with the AWS Fargate backend. Secure connection to AWS Fargate. Apigee uses the retrieved credentials to establish a secure connection with AWS Fargate. AWS Fargate processing. The request is routed to the appropriate Lambda function, for example, Lambda A, based on the API proxy invoked. The selected Lambda executes the business logic and may interact with other AWS services, like databases or storage. The common Lambda handles any shared functionalities, and the JAS system might be involved in further data processing. Response to Apigee. The Lambda function sends its response back to Apigee. Apigee processing, response. Apigee may apply additional policies or transformations before forwarding the response back to the Angular UI. UI rendering. The Angular UI receives the processed data and renders it for the user. PI as a contract. The API proxies in Apigee act as a clear contract between the Angular UI and the AWS Fargate backend, allowing both companies to work independently yet communicate seamlessly. Abstraction. Apigee abstracts the complexities of the AWS Fargate backend from the UI, so the front end remains clean and focused. Security. Sensitive credentials are safeguarded in the encrypted KVM, ensuring no unauthorized exposure. Scalability and loose coupling. AWS Fargate's serverless nature allows for scalable data processing, and the loosely coupled architecture minimizes the impact of changes in one environment on the other. In essence, this architecture lets a company using Apigee Cloud securely render an Angular UI by communicating with an AWS Fargate backend owned by another company, using APIs as the bridge. Thanks for watching, and I'll catch you in the next video.